So in this video, we're going to go ahead and tackle sockets. I think that's the next logical choice. So there's a 40-pin socket that goes over here that deals with the microcontroller or microprocessor itself. There's a 40-pin socket over here that can take any one of a number of 40-pin devices. Eventually our TIM will go in there. There is a 16-pin, it looks like, down here. It actually looks like a 14 now that I look closer at it. And for used over here, I guess we'll take, there's a 16 there. I guess we're going to, for now, pop or get 5 sockets in place. And a 14 there. I don't have enough 14-pin sockets. I find that highly curious. These really are all 16s. There's a 14 there, a 14 there. Huh. Interesting. So the sockets he kitted, 1, 2, 3, 4, 5, 6. It's almost like he got the 14s and the 16s backwards. I know all the memory 16s. Anyhow, let's get those tacked into place first. I've tried to get to the 4 corners as best as I could. That's the idea here, is to get a socket in all 4 corners. Let me set this up on something here. Don't want these to fall out as I flip it over. But all of these will be soldered. And really this will just become socket soldering. Why does the board seem to be a little bit bowed, or is it? No, it's just, there's no support over here in this corner, so. So I'm going to put a little bit of pressure down on the board, solder the corner pins. Of course, that solder flowed over the opening there, which doesn't throw me on the second hole. Say that position is for various 40-pin devices. It's where our 6530 TIM will live. We've got a 40-pin here. And it flowed over that second hole again. And we put one down here. I'll want to take a peek at all these, make sure they are flush. Not sure that one is. Yeah, it was. If it was off, it wasn't off by much. I'm going to go ahead and set in I guess the reality here is there's not a socket for every position. And that actually makes sense. These are where the 2102s go. There are 8 of them. They will each have their own socket. They are, of course, the 1K of RAM, I believe, that the system can have on the CPU card. Which back in the day could have seemed like a lot of RAM, especially given the prices back then. And of course today it's nothing. Sorry, that was a real struggle to get that to go in. I know that position's used. That one's in backwards. Notches are all the correct direction. And flowed back across the extra pad there as well. I do believe in my layout almost every position is occupied except for the, there's some prototyping or extra footprints. Which are all down here, 4 down here. Don't see anything that looks out of the ordinary with those. I guess I'm going to do all the course positions, and then we'll come back in and fill in the field, or solder up the field. After the fact, there's a little 8-pin guy that goes here. This is of course for the 555 timer. That becomes the time base for the serial port. Yeah, I show the 7417 needed here. I show a 74323 or 123 needed here. Okay, it would help if I line things up correctly. 7417 here, 123 there. 7417 here. I see what he's done. I think. Yeah, I'm not going to have enough sockets. Figure out what extra I need. I'd like to have matching sockets. I don't think I have enough to fill this. There's 324 pin. I'm surprised all 3 are here. There's a spot here for the ACIA, which is here. Boy, that was tight to get down in there. Is there a... I don't see a bent pin. So there can be 2 1702s. In our case, the monitor will go here. The ACIA will go here. That's just, those footprints are just slightly off. I know the board's a little bit warped. So I find this socket location to be interesting. Like I said, there's a number of 40-pin packages that can be put in here. And one of the interesting things is if you trace the data bus from the processor, it comes through both the ROMs, the ACIA, the serial device, ACIA, asynchronous commute, yeah, and then over to this uncommitted 40-pin, except for the data. And the data pins are all connected ahead of time. And that's because I guess in the MOS world, at the time this was designed, all the 40-pin packages had data in the same place here. And then all the other pins, of course, you can see there's the double pad so that you can connect as you need to. So I think that's just kind of cool that's how that was laid out. I don't know if I have all the logic I'm going to need or not. He supplied just enough stuff to get this on. I don't know. I don't honestly know. I feel like I'm short a bunch of sockets. I'll have to talk with Jonathan. I know I was the first one to buy the kit. And we've already discussed the termination resistors, the pull-up resistors that go along the edge here to make it into a single board system. He didn't think about it being used as a single board. So it's probably an option he'll add to add those extra resistors. So I guess I'll do a soldering montage at this point, and I'll see you on the other side. So I know for sure that all the sockets we've soldered in, except for this one and this one, are required, except for these two. I'm not sure if these two positions should be filled or not. I'm going to remove these two sockets. I'm going to clean up the little weird thing I saw on the board, unless it fell off on its own. There was a little stub of solder. It's right here. It's kind of stuck in some flux on the board. But I'm going to go ahead and attempt to remove these two sockets. Hopefully I can without destroying anything. Can't unsolder with solder, not like that. Let's see if I can draw enough solder up out of there to get the socket to drop loose. May not be able to. This may be a case of I don't want to force it. Nah, it's still got a really good grip. So I'm just going to go ahead and solder them up. I thought I'd be able to maybe unsolder them, but I'm not going to put more effort than that into removing them. You may have also realized, seen me, when there's this extra set of holes here, you want to come in from the side opposite the hole with the soldering pencil, and that helps keep the solder from flowing all the way across. I cleaned up the three that I messed up earlier. Yeah, I'm surprised there isn't enough sockets here, and I know I don't have enough machine pin in my stock to fill all these positions. I may have to buy some. There's one more 14 pin floating someplace. Right there. I know this one's used because it's a 7404, I believe, and well, maybe not. I think the 7404 is right here. I don't know if this position is supposed to be used or not, but it's getting a socket. Assuming I can get it to take solder and look decent, because some of those solder joints are really terrible. Well, if the tip wasn't covered in oxide, it might solder better. If your tip is dark, it's got all that oxide collected on the soldering pencil tip. That oxide's an insulator, and it'll stop the pin and pad from heating up. And you'll get what you saw happen to me there, where things just aren't taking solder well. Solder joints are looking funky, as they do here. Some of these just aren't very good. And I think that's because I had let the tip get too dirty. Things weren't flowing well. So 6501, 1702A with the monitor, the ACIA synchronous communication adapter, whatever it's called, 2102s. There'll be a 74123 here and a 7417 here that are used to create the two-phase clock. These are bus drivers that I don't need. In this case, they wrap around to drive over here. I don't need those, I don't think, at this point. I need the logic over here, so it's kind of a mystery to me. There's two 16-pin sockets left. 14 and a 16. I just kind of assumed all these positions required parts, except for these two that it said right in the manual about it. If you're doing a standalone, you don't need to fill those. And my intent at this point is still standalone. I'm not 100% locked into that. Why did you fish around so weird? Yeah, there's a decoupling capacitor that goes off that end down there, so that is correct. And that is where the 74123 dual one-shot goes. Like I say, ultimately generates the two-phase non-overlapping clock with the 6800 and the 6501 require. The 6502 simplified that. It uses just a single clock. I've said this in previous videos, and I'll say it in this one. When Motorola sued MOS for basically copying their pinout and being, socket compatible, and MOS ended up creating the 6502. Whether they would have created the 6502 or not, I don't know. But the 6502 ended up with a single clock. It ended up a little simpler to implement in a system, and that simpler to implement, I think, is what helped drive adoption in the Commodore and the Atari world, just because it was a little bit simpler to interface to implement, a little bit cheaper. You didn't need two chips to create a two-phase clock. So another 16-pin position that needs a socket. 14, 14, 14, 14, 14, 14, 14, 14. Do I have an extra 16 pin? It could go up here, but I don't really need those in this case, so I'm not going to solder anything in there. So anyhow, I will see you in a future video.